over 5. You can put this in a calculator and check the answer out. Then you can put this in the calculator and check the answer out. And you find that both these answers are exactly the same. So both these numbers represent the same value. Right, let's do number 2. So in number 2, I must not worry about the numerator. I must only worry about the denominator. So it's square root of 8 over square root of 8. So on the top, I get square root of 7 times square root of 8. In the bottom, I get square root of 8 times 8. Now, you know on the top, that is really square root of 56 because 7 times 8 gives you 56. In the bottom, you got square root of 64. 8 times 8, 64. So, on the top, you got square root of 56 over square root of 64 is 8. So you have rationalized the denominator there. Right? I'm going to do number 3 on a new page because I need a lot of space. Right. So in this example, we'll have to multiply by, look at the denominator, square root of 5, square root of 7. Because this is plus, here we must have a minus sign. Right. Now, 5 times the numerator. 5 times square root of 5 minus square root of 7 over square root of 5 plus square root of 7 into square root of 5 minus square root of 7. Once again, this is like a plus b into a minus b, which is a squared minus b squared. So the numerator is 5 into square root of 5 minus square root of 7 over. This is a. A is this. So it will be square root of 5 squared minus. This is b. Square root of 7 squared. So the numerator is 5 into square root of 5 minus square root of 7 all over. 5 squared, by now you know that square root of 5 squared is 5. Square root of 7 squared is 7. So this is 5 minus 7. So the numerator is 5 into square root of 5 minus square root of 7 all over. 5 minus 7, which is 2. Sorry, not 2. 5 minus 7, which is minus 2. So, that's your answer for number 3. Right. Here we have 4 over root 3 minus root 5. So, we have to multiply by root 3 root 5. Since there's a minus in the denominator, we must put a plus there. And we must put a plus there. Since there's minus here, you must put plus and plus in both places. Right. The numerator will be 4 into root 3 plus root 5 over. Denominator will be root 3 minus root 5 into root 3 plus root 5. See this times that. Now, that's 4 into root 3 plus root 5 over. Again, this is a plus b into a minus b, which is a squared minus b squared. So your a here is root 3 squared. And your b here is root 5 squared. Right, so that's 4 into root 3 plus root 5 over. This 3 squared is 3. Root 5 squared is 5. So you're left with 4 root 3 minus root 5 all over. 3 minus 5 is minus 2. Now, this is a very interesting example. That 4 can be divided by this minus 2. That 4 can be divided by this minus 2. 4 divided by minus 2 will give you minus 2. So the final answer is minus 2 into root 3 minus root 5. So that's your final answer. Minus 2 into root 3 minus root 5. Alright, so those are the 4 examples on rationalizing denominator. Right? There are lots of more sections to be covered, but these are the basics on surds. And if you know these basics, then you can go on to answer other questions, much more complicated questions. But our aim here is to just give you the basics of surds. Alright, so this will bring us to the end of the basics of surds. And if you know these basics, you will be able to do many complicated examples, but you got to know these basics. Alright, so bye till we meet again.